Hello students, welcome back to the lecture series of Mechanical Properties of Fluids. This is lecture 4 of the series. The topic with which we are going to start today's lecture is nothing but mercury barometer. It is nothing but a device used to measure atmospheric pressure. So let us understand the construction of this device and its working, and let's see how does it help us to measure the atmospheric pressure. Okay. So let's start first with the construction of mercury barometer. As we can see in the figure, it consists of a long glass tube, which is 1 meter long, whose diameter is 1 centimeter. And initially, this long glass tube is completely filled with mercury. Later, we take this tube and we invert this tube into a small mercury dish, as shown in the figure. Now, when we invert this tube, some mercury spills into the dish, and therefore the level of the mercury drops inside the tube, because of which a gap is created at the top of the tube. This gap mainly consists of mercury vapors, and it is called as Torricelli's vacuum. Now, since it is vacuum and we know that vacuum is basically definition of zero pressure, we can say that the pressure at point A in the figure is nothing but zero. Okay. Now we have already established the fact that the pressure at point A is zero. Let's find out the pressure at point B. To reach point B, we go down by depth h into the mercury to reach point B from point A. Therefore, pressure at point B can be written as PA plus rho g h, where rho is nothing but the density of mercury, g is nothing but the gravitational acceleration, and h is nothing but the depth by which we go down while traveling from point A to point B. Let's pay some attention to point C. We can see that the point C is basically open to the atmosphere, and therefore whatever pressure is acting at point C, it is nothing but atmospheric pressure. So we can write down PC is equal to P atmospheric. Now, point B and point C, point B and point C, they both are in same fluid, which is nothing but mercury. Point B and point C, they both are in same fluid, which is nothing but mercury, and they are also at same horizontal level, and we know that whenever 2 points are in the same fluid and at same horizontal level, the pressure at both these points must be same. Therefore, pressure at point B is now equal to pressure at point C. So we can write down in place of pressure at point B, which is PA plus rho GH, and in the place of pressure at point C, we can write down PATM. But we know pressure at point A is 0. Therefore, we get the atmospheric pressure is nothing but rho GH. Now, what is evident from this formula is that if we measure H, which is if we measure height of mercury column in barometer, and if we put that height into the formula PATM is equal to rho GH, we can directly measure atmospheric pressure. Thus, mercury barometer, by simply allowing us to measure the height of the mercury column, helps us to calculate the value of atmospheric pressure at that point. So this is mercury barometer with the formula PATM is equal to rho GH, which helps us to calculate atmospheric pressure. Okay, so we just saw in mercury barometer that if we measure the height of mercury column and put it into the formula PATM is equal to rho GH, we can easily calculate the atmospheric pressure. Now let's do a small numerical exercise where we substitute the value of PATM and find out the value of height of mercury column. So, in place of PATM, we substitute 1.013 into 10 to power 5 pascals. In place of rho, we substitute 13,600 kg per meter cube. In place of G, we put 9.8 and we calculate H. When we do the calculations, we see that the height comes out to be 76 centimeter. Therefore, the atmospheric pressure, we say that it is equivalent to pressure exerted by mercury column of height 76 centimeter. Okay, so therefore, we can say that the atmospheric pressure is equivalent to pressure exerted by mercury column of height 76 centimeter. So this exercise basically gives us a new methodology of representing pressure, which is in terms of height of mercury column. Okay, so using this methodology of representing pressure in terms of mercury column, we could derive a new unit for pressure called as torr. So let's see what is this torr. So we define 1 torr as a pressure equivalent to, so pressure exerted by 1 mm mercury column. So if we have a mercury column of height 1 mm, then the pressure exerted by that mercury column is nothing but 1 torr. Now let us calculate. So we use the formula P is equal to rho GH. In place of rho, we put 13,600. In place of G, we put 9.8. And in place of H, we put 1 over 1000 because 1 mm is 1 over 1000 meter. When we do the calculations, we see that the value comes out to be approximately 133.3 pascals. So, thus by using the methodology of representing pressure in terms of height of mercury column, we could derive a new unit for pressure called as torr, whose value is equal to 133.3 pascals. And we define 1 torr of pressure as the pressure exerted by 1 mm of mercury column. So this was all about mercury barometer and how it is used to measure atmospheric pressure. Now let us move towards the next instrument, which is nothing but open tube manometer. Okay, before moving on towards the open tube manometer, we first need to understand what is gauge pressure, because open tube manometer is a device that measures gauge pressure of the system. So let us first define gauge pressure. I'll read out the definition. It is the pressure of the system. I'll just change the color. Okay. It is the pressure of the system over and above atmospheric pressure. So the pressure of the system over and above atmospheric pressure is called as gauge pressure. So basically, if we want to calculate gauge pressure of the system, we just need to subtract atmospheric pressure from the pressure of the system, which is also called as P absolute. So to find out the gauge pressure of the system, we subtract the atmospheric pressure from the absolute pressure of the system. So we have an example where they have given that the absolute pressure of the system is nothing but 3 bar, and they've asked us to calculate the gauge pressure of the system. So we know the formula that the gauge pressure of the system is nothing but the absolute pressure of the system minus the atmospheric pressure. Now the absolute pressure of the system is given as 3 bar, and we know that the atmospheric pressure in bar is 1.013. And when we do the subtraction, 3.000 minus 1.013, I think it basically comes out to 1.987 bar. 1.987 bar. So this is gauge pressure. Now let us understand open tube manometer, which is nothing but an instrument used to measure gauge pressure of the system. Okay, so let's move on towards the last topic of this lecture, which is nothing but open tube manometer, which is basically a device used to measure the gauge pressure of the system. Now, let's first start with the construction of open tube manometer. So, this open tube manometer consists of a U tube as shown in the figure, and it is filled with a low density liquid, mostly water or kerosene. Okay, so this U tube consists of two arms. On the left hand side, we have one arm that is open to the atmosphere, and on the right hand side, we have the other arm which is connected to the container. Now, this container consists of the system whose pressure we want to measure. So basically, the container is filled with gas whose pressure we want to measure. So over here we have the pressure, here we have the gas whose pressure we want to measure. Now, we can see that in the U tube, there is a difference in the level of liquid in both the arms. But initially, when the system is not connected to the U tube, or when the container is not connected to the U tube, the level of liquid in both the arms of the U tube is same. So let's say this was the initial level of the liquid in the U tube. So what has created a difference in the levels of the liquid in both these arms? So what has happened is actually when we connected the container to the U tube, the gas in the container now has created a pressure which is acting on this point which I have darkened over here, because of which, because of this pressure, the level of liquid goes downwards in the right hand side arm, and the level of liquid goes upwards in the left hand side arm. Okay, now let's start with the mathematical part of the derivation, and let's try to prove that this open tube manometer indeed helps us to measure the gauge pressure of the system. So let's start with point A. So the pressure at point A, since it is open to the atmosphere, is nothing but atmospheric pressure. The pressure at point B is equal to pressure at point A plus rho g h, because we are going downwards by a depth of h. Now in place of PA we can write down PATM and plus rho g h. Now we can see that the points B and C are at same horizontal level. Therefore, we can write down pressure at point B is equal to pressure at point C, because they are in the same liquid and they are also at same horizontal level. Therefore, we can write down pressure at point C is nothing but pressure at point B, which is nothing but PATM plus rho GH. So pressure at point C is nothing but PATM plus rho GH. Now, we can see that there is a downward arrow acting at point C, and that downward arrow is representing the pressure exerted by the gas on the liquid in the U tube in the right arm. So basically, we have the gas over here, and that gas has entered the U tube, and the gas now also exists in the right hand side arm of the U tube. Now, this gas is an enclosed fluid. So whatever pressure it has in container D, so whatever pressure is at point, I'll just change the color. So whatever pressure is at point inside the container, let's say that pressure is P, the same pressure is acting at point C, because the fluid in the container and in the U tube, it's an enclosed fluid. And we know, according to Pascal's law, the pressure at any point in an enclosed fluid is equally transmitted to all the other points in the fluid. So the pressure P inside the container is equally transmitted to point C. So by using this concept, we can write down PC is nothing but P. PC is nothing but P, which is nothing but absolute pressure of the system. absolute pressure of the system. So in place of PC, we can write down P absolute, which is P ATM plus rho g H. And when we take the atmospheric pressure on the other side, we get P absolute minus P ATM, which is equal to rho g H. And this P absolute minus P ATM is nothing but P gauge, which comes out to be rho g H. So thus, we can see that by simply measuring the difference in the liquid levels in both the tubes of the open tube manometer and substituting it in the formula P gauge is equal to rho g H, we can easily measure the gauge pressure of the system. So thus, we have understood both the pressure measuring devices, which is nothing but mercury barometer and open tube manometer. We have also understood the difference between them, like how one measures the atmospheric pressure and the other measures the gauge pressure of the system. So that's all for today's lecture. We'll meet again in the next lecture of this series. Till then, keep studying. Thank you very much.